Hey everyone, so you clicked on this video because you're interested in learning the basics of mutually exclusive events and independent events. These two concepts are really easy in mathematics, and in this video I'm gonna help you understand those two concepts. If this is your first time visiting my channel, my name is Peter. I make math tutorials covering different math topics. So if this is content that you find interesting, please consider subscribing and also share this video with somebody who'd benefit from this content. Now, if you're ready, grab your calculator and let's get started. So the probability of compound events simply means that these events involve more than one event. In the previous video, we saw that some probabilities only involve one event, but whenever you have two or more events that are linked by the word and or the word or, then those are compound events. Those events are a little bit more complex. So there are two concepts that we're going to see in this video, and those two concepts are mutually exclusive events and independent events. I'm going to define each event later on in the video with examples. So the first concept is mutually exclusive events. When two events have no outcomes in common, then those two events are mutually exclusive events. So the outcomes, if they are common outcomes, that means the two events overlap. Now, if those two events are mutually exclusive, when you try to calculate the probability of A and B being two different events, that probability will be equal to 0 because the two events do not have a common outcome. Now, I'm going to illustrate this concept using these two diagrams. The diagram on the left here indicates that you have an event A and another event B, and because they don't have a common outcome, you see that the two circles do not overlap. Now, if the two circles overlap, that means they have a common outcome, A and B. So we use this symbol here in the middle that looks like a letter N to indicate that there is an intersection. So let's take a look at some examples how this would work. So how do you calculate the probability of A or B? So the first thing you need to determine before you start calculating a probability where it is either A or B, you need to determine if they are mutually exclusive. If they are mutually exclusive, that means that the probability of A or B would just be equal to the sum of the probability of event A plus the probability of event B. Using a diagram, you'll see that the two events here are mutually exclusive. They don't overlap, so you just add the two individual probabilities. On the other hand, if they are not mutually exclusive, that means they have a common outcome, then the probability of A or B will be equal to the probability of A plus the probability of B minus the probability of A and B. So what we're doing in the second scenario here is we're subtracting that region where the probability overlaps. So where they overlap, they have a common outcome, we need to subtract that probability. Now, why are we subtracting is because we're going to be double counting the events that are happening there. That's why we're subtracting. So the first example we're going to look at is going to involve a die, a fair die. So suppose you roll a fair die. What is the probability that you roll a 2 or a 5? So the first thing we want to do is to determine whether these two events are mutually exclusive. So how do we do that? Is it possible for us to roll a die and get a 2 and a 5 at the same time? The answer is no. So those two events do not have a common outcome. They do not overlap. So all we're going to do is just find the probability of getting a 2 plus the probability of getting a 5. Now, the probability of getting a 2 is going to be 1 out of 6 because there are 6 possible outcomes, but there's only one favorable outcome. And then we add 1 out of 6 because there are 6 possible outcomes, but only one favorable outcome to get a 5. So when you add them together, you get 2 over 6, and you must simplify that fraction to get 1 out of 3. So that's the probability of getting a 2 or a 5. Now, second question, suppose you roll a fair die. What is the probability that you roll a 2 or a prime number? So the first thing we need is to figure out if there is a common outcome. Are they mutually exclusive? So is it possible to get a 2 and a prime number. Can those two events happen at the same time? And the answer is yes. So let's see how we're going to figure out this probability. So we're going to be adding probability of 2 plus the probability of a prime number. I'm going to use the letter P to represent a prime number, and then we need to subtract the probability of getting a 2 and a prime number. So that's the that's the common outcome, a 2 and a prime number, because the number 2 is also a prime number. So the probability of getting a 2 is just 1 out of 6 because there's only one number 2, plus the probability of a prime number is 3 out of 6. There are 3 numbers on a die, that is 2, 3, and 5. And then we need to subtract the common outcome, which is just the number 2. The number 2 is also a prime number, so it's going to be 1 out of 6. So when you add and subtract those fractions, you get 3 out of 6, which is equal to a half. So the second concept involves independent events. So when two events are independent, it means that one of the events does not affect the probability of the second event. So how do we calculate them? Well, probability of A and B is equal to the probability of A times the probability of B. So typically, if you want to know if they're independent events, you'll probably see that keyword and. If you want to know about probabilities involving mutually exclusive events, you'll see the word or. So let's see how to calculate the independent events using probability. Example number 2. So let's look at some examples. And the first question here says, suppose you roll a red die and a blue die. The dice here have 6 sides each. What is the probability that you will roll a 3 on the red die and an even number on the blue die? So we want to ask ourselves, are these two events independent of each other? So let's think about it. When you roll a 3, is it going to affect the probability of getting an even number on the other die? And the answer is no. They're not going to affect each other. So we're going to calculate the probability of 3 and an even number. That means the probability of 3 times the probability of getting an even number on the blue die. The probability of a 3 is just 1 over 6. There's only a 3, there's only one 3 on the red die. To get an even number, there are 3 even numbers on the blue die. So 1 over 6 times 3 over 6 is 3 over 36. When you simplify that, you get 1 over 12. That's the probability. The second question says, suppose you roll a red die and a blue die. What is the probability that you will roll a 5 on the red die and a 1 or 2 on the blue die? So this second question is a bit more complicated because we have to sort of calculate a probability within a probability. But the first thing we need to know is, we need to understand is, are the two events here independent? When you roll a 5 on the red die, is it going to affect the probability of getting a 1 or a 2 on the blue die? And the answer is no. So they are independent. Probability of 5 and the probability of 1 or a 2, we're going to find the probability of the 5, which is 1 over 6, times. Now, the probability of 1 or 2, we need to think about, are they mutually exclusive? So if you're going to get a 1, you cannot get a 2. So those two events are mutually exclusive. They do not overlap. They don't have a common outcome. You're either going to get a 1 or you're going to get a 2. So the probability of getting a 1 is 1 over 6, and I'm going to add that to the probability of getting a 2, which is also 1 over 6. So once I get that sum, I'm going to multiply it by the probability of getting a 5. So 1 over 6 times 2 over 6. So 1 over 6 plus 1 over 6 is 2 over 6. And that product is 2 over 36. And you simplify that to 1 over 18. This is the probability of rolling a 5 on the red die and a 1 or a 2 on the blue die. So here's some more examples. So the instructions read, you choose a card at random from a deck of cards. A deck of cards has 52 cards. What is each probability? So the first scenario is you're going to select either red or a number. So when you see that keyword or, you know that we're most likely going to be looking at a mutually exclusive scenario. So the first thing is to figure out, are the two events mutually exclusive? So is it possible you can choose a card that is red and it's also a number? And the answer is yes. So these two events are not mutually exclusive.
So that means we're going to calculate the probability of red plus the probability of getting a number minus the probability of getting a number that's red. So what are those probabilities? The first probability here of getting a red color is 26 over 52. So when you look at a deck of cards, half of the cards are red. And then the second probability is getting a number. So when you look at all the cards that have numbers are only 36. 2 to 10 are 9 cards, and there are 4 suits, and so 9 times 4 is 36. Now we need to subtract the cards that are going to be double counted, and those are the cards that are red, that are numbers that are red. And so those cards are 18. So when you subtract them, your probability is going to be 44 over 52. Simplify that fraction by dividing by 4, and your probability is 11 over 13. The second question is finding the probability of selecting a red or a card that's red or it's number 5. The probability here is we need to figure out, are the two events mutually exclusive? Is it possible to select a card that is red and it's also number 5? And the answer is yes, so they're not mutually exclusive. So we're going to add the probability of picking a red card, the number 5, and then subtracting cards that are red and number 5. So 26 plus 4 is 30 minus 2 is 28 or 52. Simplify that fraction by dividing by 4 and you get 7 over 13. The final problem says probability of choosing a card that it's black or it's a face card. Is it possible that you can choose a card that's a face card and it's black? The answer is yes. So these two events are not mutually exclusive. That means we're going to add the probability of the black card, a face card, and then subtract the overlapping event, which is a card that's black and it's a face card. 38 minus 6 is 32. 32 divided by 52, and you simplify that fraction and you get 8 over 13.
All right, so that's pretty much it. Mutually exclusive events and independent events are easy concepts. Anybody can understand them. As always, if you found this content useful, please make sure that you share the video with somebody, like the video, and subscribe to the channel so that you can get notification whenever I upload new videos in the future. Until next time, bye-bye.